Hello and welcome wherever you are. Today we are going to look at how we can determine the number of moles of water of crystallization, that is to say the X in the water of crystallization. Such questions are common in mole concept, but we might encounter it somewhere, so let's have a look at how we can deal with it. Hydrated magnesium sulfate has a formula mass of that. Determine the value of X in magnesium sulfate X water. So all we need to know is we should be able to determine the relative formula mass of our magnesium sulfate X water. So we have to first determine the relative atomic masses of the corresponding elements so that we can be able to find the value of X. So when you check the periodic table, magnesium will have 24, our sulfur will have 32, we are adding up. Our oxygen, we shall have 16 times 4, which is 64. So 24 plus 32 plus 64. So the total we are having is 120. So magnesium sulfate weighs 120 grams. However, the whole of our compound weighs 246.4. So that means our X water will be providing the 246.4 minus the 120, let us say 0.0. So what do we get? 246.4 divided by, minus answer. So we get 126.4 grams. So that means the X water is contributing 126.4. However, when you look at our X water, it means that our water molecule, hydrogen 2 times 1, which is 2, plus oxygen, which is 1 times 16, a total of 18. That means each water molecule weighs 18 grams. So how many 18 grams can we get from this? So that means we shall get the 126.4 divided by 18. Then we shall get the value of X. So answer divided by 18, so which is roughly equal to 7. So that means X is equal to 7, and our formula will be magnesium sulfate 7 water. You might have had a look at it in our previous video of water of crystallization. So X is equal to 7. Let's have a look at another question. Hydrated sodium carbonate has a formula mass of that, 286.0 grams per mole. Determine the value of X in sodium carbonate X water. Feel free to pause the video as I give you a couple of minutes. Seconds. Okay, so let us see how to deal with it. Still, we need to get the relative atomic masses of the elements present in our sodium carbonate. So our sodium carbonate X water. Remember, we have already seen that our water has a molecular mass of 18 grams. So our sodium, this is 23 times 2, which is 46, plus our 12 times 1, which is 12, then plus, this is for carbon, plus 16 times 3, which is 64, right? We can also add on this plus 18x, 18 coming from water, so plus 18x. This should be equal to our total, which is 286.0. This is the same method like our previous example, just that I've put all the different parameters on the left hand side. So we have 46 plus 12 plus 64, which is 122. So 18x will be equal to 286.0 minus 122. So if you subtract, we shall get 164. So 18x is equal to 164, and x will be equal to 164 divided by 18. So you shall roughly get 9. So obviously if you have some very small decimals attached, that is allowed, but we shall round off to the nearest whole number, which is roughly equal to 9. Did I blunder somewhere? Okay, I think I did. 16 times 3 is not 64. 16 times 3 is 48. Sorry about that. So here we have 48. So 46 plus 12 plus 48 is 106. So we shall have minus 106. 286 minus answer, which is 180. And 180 divided by 18, which is 10. Hopefully this is the same answer you got after pausing the video. So how did I know? Basically because sodium carbonate is usually a decahydrate. That's why I somehow thought my answer is wrong. So that's how we can find the value of X in sodium carbonate decahydrate. Then lastly, hydrated nickel chloride has a formula mass of 237.7 grams per mole. Determine the value of X. In this case, all you have to do is to find the relative atomic masses of the corresponding elements, nickel, chlorine, and so on. Please let me know the answer you get in the comment section and see whether we have similar values of X. Thanks for watching. Stay safe. Don't forget to subscribe, like, and share.